Welcome to the 2025 AIME 1 problem series. Today we're going to be doing problem number 4, and we want to find the number of ordered pairs x, comma y, where x and y are both integers between -100 and 100 inclusive, such that this weird equation is satisfied. And so at first this equation honestly looks a bit intimidating, but what we can do is we can actually factor it, and that will simplify this problem a lot. And so we can actually write this as a product of two binomials. And the best way to do that is to look at 12. And noting that the coefficient of the middle term is quite small, we want the factors that we pick for 12 and the factors that we pick for 6 to be like roughly equal or roughly around each other. So for 12x squared, we can look at this and we can tell that we should pick 3x, 4x, and for 6y squared, we should pick 2y squared and 3y squared and place them in this area such that when we put the negatives, we put it right here. And so what that's going to do is on the outer terms, we're going to have negative 9xy, and on the inner terms, we're going to have 8xy. And those will add up to give us our negative xy. And so now this actually simplifies the problem to just two cases. We have either case one, where the first binomial is equal to 0. So if we have 3x plus 2y equals 0, well, that's the same thing as y equals negative 3 halves x. So that's our first case. And if we have case 2, where the second binomial is equal to 0, well, that's the same as y equals 4/3 of x. So let's deal with these two cases separately. Well, we know that x and y are both integers between -100 and 100. And so what we can do is we can bound y. So we have, I'll go ahead and do this in different color. Um, let's do, let's do, let's do this. So actually, I think blue is going to look better. So we know that -100 has to be less than or equal to negative 3 halves x, which has to be less than or equal to 100. And so what we can do is we can multiply both sides, or not both sides, each of the three things by -2/3. So obviously multiplying by a negative number is going to flip the signs or flip the inequality signs. Here we're going to have 66.66 repeating, and then 66.666. And then here we're going to have x. Here we're going to have negative 66.666 repeating, right? And so what we also know is that x must be divisible by 2 in order for y to be an integer. Since if x isn't divisible by 2, we're not going to get y being an integer. So we can actually substitute x for 2x. Or for not for 2x, sorry. We can substitute x for 2k. So here x is equal to 2k, where k is a positive integer. Or not necessarily a positive integer, just an integer, since x can be negative. And so we can divide both sides by 2 here, and we're going to get 33.333 repeating is going to be greater than or equal to k, which is going to be greater than or equal to negative 33.3 repeating. And so this will give us how many values for k? Well, we know that we can technically like ignore these 0.333s since we know that k is an integer. And so on the positive side, it can be anywhere from 1 to 33. So that gives us 33 numbers. On the negative side, it can be anywhere from -1 to -33. That gives us another 33 numbers. And then we also can't forget about 0. So we have 67 total for this case, for case 1. I'll actually go ahead and box it just so in a color so that we know that this is case 1. Or circle it. So that is case 1. Okay. Well, now let's look at case two. And so in case two, we know that y is equal to 4/3 x. So we can write that negative 100 is less than or equal to 4/3 x, which is less than or equal to 100. Here we can just divide everything by 4/3, same as multiplying everything by 3/4. And so we're going to get this. And then here, note that x is going to be, or well, our case technically for this one should be x is equal to 3a for some a being an integer. And this is because we know that x must be divisible by 3 here. X must be divisible by 3. And so we can substitute that in, and we're going to get, um, when we divide everything by 3, we're going to get negative 25 less than equal to a, which is less than or equal to 25. And so this is going to give us, well, 25 terms on the negative side, 25 values for on the positive side, and obviously 0. And so we are going to get 51 here. And so now it seems like we have the answer, right? We have our total values for both of our cases. We have 67 and we have 51. And so it seems as if our final answer is just going to be 67 plus 51. And that is going to be 118, right? No, it's actually not. And the reason for that is because we selected that A is going to be 0 in this case, and in this case, K is going to be equal to 0. But what's important is that if K and A are both equal to 0, that means X is equal to 0 on both cases, and Y is equal to 0 on both cases. So we're actually overcounting this pair. We're overcounting it. And so we're counting it twice when it should only be counted once. So actually, our correct answer should be taking 67, 51, adding them, but subtracting 1 in order to correct for that overcounting. 67 plus 51 minus 1 gives us our answer of 117. And that is your final answer. Thank you for watching and have a great day.